Hello, welcome to the presentation of the reinforced concrete beam design, and we're following ACI 31808 with compact sections embedded into Excel. It's not in scope to cover the method of ACI 31808. There is a presentation that's a three-part presentation at civilpe.net. And I'll go find that for you. It's a series of videos that walks you through step by step of doing the concrete beam design for rectangular and T-beams. So now let's open up the spreadsheet and take a walk through. You can find the compact sections Excel spreadsheet underneath, after you do your installation, underneath Program Files x86, Structures Office, Compact Sections, Documents, and you want this document right here. And when we open it up, we'll see that there's three sheets to it. A rectangular beam design, a T-beam on the second sheet, and then the third sheet is kind of the database of what's used in the other two spreadsheets. Here's your geometry of your various rebar. Here's your concrete materials, and each concrete, if you want to add one, you'd put a name, give it the yield stress and the allowable maximum strain. And the same for steel materials. If you want to add a steel, you give it a name, the E, and the yield stress. This is just used to aid the pull downs in the spreadsheets. So let's just start out with the rectangular beam. And you'll see up here the assumptions. The moment is positive, compression on top. Plane sections remain plane. Tensile strength of concrete is neglected. Concrete is not lightweight. Lambda for VC is 1. The compressive strength of steel is ignored, and the maximum strain is 0.003. So to use the spreadsheet, you'd input your concrete geometry, the width and height of the rectangle, and the edge distance, the distance from the bars to the edge of the concrete. How many bars are on top and the rebar, and you can just select which rebar you want. Same for the bars at the bottom, and how many rows and what the rebar is, and this is the number of bars per row. The stirrups, we're using a number 4 for the stirrup, and they're spaced every 12 inches along the beam. The concrete material that we're going to use, we have 2 in our database. We used ACI 6000, and we chose steel from the database. And again, I'm talking about what's over here in the materials definition. Our design moment. And when we execute, when we pick build and design, it will compute how much steel area is required. And then down here is our moment capacity in kips feet and the shear capacity in kips. Over here, just as a check, in the that PE civil PE videos, they give examples, and so when we put the same inputs that they put into the video, we should get these answers. That's why this is here. So when we pick build and design, we'll see it goes through and constructs the section and tells us that it's done. And here it will tell you whether it failed or passed on the amount of required steel. And this is your moment capacity and your shear capacity. The T-beam So Here it's the same set of assumptions that we saw for the rectangular beam. And the width of the flange, that's this distance here. Depth of the flange, distance between these 2 points. Depth of the beam, that's the distance from here to here. Width of the web, that's this here. And edge distance, the distance from the rod to the edge. And which concrete we're using. Again, the number of bars on top. We chose 3. And bottom bars, number of rows, number of bars per row. We select our rebar. The stirrups, we're using number 4, 12-inch spacing. We're using the common steel material definition. When we press that, it goes through, constructs the beam. And if we've input the same our moment capacity should match for 2 rows, it should be 493. And if we set this to 1 row, number 6. Okay, for 1 row, rebar is number 6. Number of rows. Number 6. 1 row. And we'll click. And we see down here 125. So if we had 1 row of rebar on the bottom, when we set it to number 6, the allowable is 4,000. We use the concrete 4,000 up here. Stirrups, number 4, and that matches our metal. And we should get the same answer. Now if we changed it to 2 rows of number 9 at the bottom, let's go to 2 rows of, for 2 rows, number 9, 4,000 psi, we're using that material. So this tells us we've got adequate steel, and the moment capacity is 493 kip feet. So now let's go into how to program it.